this is called the critical, I think it's called, I really should be double check. It's called the critical value method. I call it the 4-step. I call it sometimes in the video the 4-step method. I sometimes call it the shortcut method, because if you recall how we learned doing this last time, or 5 times ago, we did it by trial and error. It was much longer. This is also called the 4-step method. It's called the shortcut method. But there's another approach for those who've been doing the online homeworks, or perhaps I said that we talked about this in class last time. What's another totally different approach that will give you the capacity to get the answer as well? And what I'm alluding to, and again, is the p-value approach. In other words, if you could calculate a p-value and then use it, you basically can apply the rule, get the, in other words, you want to get an answer. Do I reject or accept? So I'm going to sort of walk you through the steps, since I'm not demonstrating it. Perhaps I should demonstrate it, but I'll walk you through the steps. You type the numbers into pH-stat, the average, the mu, the alpha, the standard deviation, the sample size, everything gets set, and the computer will calculate this number for you. You'll see that same number on the page someplace. But then the pH-stat's going to give you something called a p-value. So the other approach is called the p-value approach. These are all more or less the same thing. Method. So the computer will calculate a p-value for you, and let's call that p. And just to repeat the rule that I told you last time, if the p is lower than the alpha, you're supposed to interpret that as to reject a 0. And if the p is bigger than or the same as alpha, then you do not reject a 0. So if you know the if you know the p-value, or you can get it relatively easy by using pH-stat. You can't do it an in-class test. You can't do it, but you're not having an in-class test. Then you can calculate the get the answer that way. So you don't have to. Do you have to put down the hypotheses? Well, unless you put down the hypotheses, you don't know what you're proving. So you always have to put down the hypotheses. Do you have to do the calculation? Not really. If your computer's doing it for you, why calculate it? And you have to look up a number in the back of the book? Not really, because all you're going to really care about is the p-value. The computer, if you type in the numbers in the right spots, you're going to get a p-value, which can then be very easily interpreted. To repeat the reason why it works, based on what I told you last time, what the computer essentially is doing is the following. It looks at, it knows that, you gave it all the relevant numbers, so it knows that the t-value is minus 1.75. The computer also knows in its memory, so to speak, the equation of the t-diagram. It then calculates, so where is minus 1.75, let's say, is over here. It calculates the area to the left of minus 1.75. And that number is going to be called a p-value. So you think, since it's to the left of the rejection region boundary, it has to be lower than 5%, right? I mean, this little piece here is a subset of this big piece, so it has to be lower than 5%. And therefore, if it's lower than the 5%, that means you ended up in the reject region. So if you, now, how could you calculate the p-value by yourself? Technically, yes. If you have a TI-84 calculator, you could theoretically, type it into the calculator and get the same thing. But, or if you actually, did it really carefully, made a picture and started estimating this area. But let's avoid all that. Just go right to the pH-stat. And by the way, you don't have to use pH-stat. There are probably dozens of programs on the internet that will help you calculate a p-value for you, but I think pH-stat happens to be one of the easier ones. So you might as well use it since you have it as part of the back of the book.